So I'm speaking to you today from Naarm, which is the Wurundjeri name for Melbourne in Australia. And I acknowledge the continuing connection of the Wurundjeri people of the Kulin Nations to land, to waters and to culture. Sovereignty was never ceded. I pay my respects to elders of the Kulin Nations, past and present, and extend this respect to any Aboriginal and Torres Strait Islander elders who are joining us today. So welcome everyone to our final session of the JCIOI Workshop. If you were unable to join us for the opening session or any of our previous sessions, JCIOI is the Joint Commission on Ice Ocean Interactions, and it is a joint commission of IACS and IAPSO, both of which are associations of the IUGG. The aim of the Joint Commission is really to address fundamental knowledge gaps in ice ocean interactions, and that's through facilitating and engaging in research and development related to understanding, observing, and modelling ice ocean interactions. So our real aims as part of this Joint Commission are to identify and address unknowns in ice ocean and interactions, and then to help build connectivity and collaboration across groups and initiatives. So that's really why we're hosting this workshop. And then if you could advance these. And just one, sorry, back one, yeah. So the aims of the overall workshop here are then to focus on this, to bring out what are some of the key knowledge gaps as identified by the community, and then to think about how we can start to address them as a community. All of the sessions are recorded, the keynote sessions that is, and they should be uploaded already onto our YouTube site, which you can access through that website link that's on the slide there. As you come in, I'd ask, if you have not already, that you please mute your microphones as well. And if you want any more information about us, please do head to our website, or you can get in contact with us via email, which I'll share towards the end of this presentation, and also our Twitter account. Next one, please. So this is our final session. We've got a few things planned, the first of which is a session, some linkages talk. So these are initiatives from different groups in the community. And the aim of this session is really to understand what's going on in ice ocean interactions research, and then to kind of facilitate interactions between different groups. It's really critical that I highlight here that these are a few of many initiatives on ice ocean interactions, and we really hope that in future workshops we might broaden the discussion and hear more from lots of different people, and how we as a community can more effectively collaborate. So our first hour is going to be hearing from five different folks, 5 different initiatives, followed by the second hour where we'll hear some short talks, and then we'll finish with a workshop summary and outlook. So you could go to the next slide, please, Helen. So we're going to be hearing from Dr. Keith Nicholls, Dr. Kirstin Schulz, Dr. Alessandro Silvano, Assistant Professor Jan de Rydt, and Dr. Ben Galton-Fenzi. So each will have 10 minutes to talk, and then we'll have time for one or two questions directly following their talks, and then we'll have a question session at the end of that. So we might get started straight away with Keith. Oh, and I should say as well, I'll put my hand up at 8 minutes just to remind you how you're going for time.
Yeah, so we're going to get started on the first of this activity. And so Keith Nicholls is going to talk about the necklace project. So Keith, please feel free to share your slides, and we'll have like 8 minutes, take 8-10 minutes, and then maybe time for one quick question before moving on to the next initiative.
Okay, can you hear me okay?
We can hear you okay. We see your slides. I don't know if you might want to do it full screen.
Yeah.
Right,
thanks very much.
This is perfect.
Great stuff. Okay, so yeah, this is Keith Nicholls from British Antarctic Survey, and I've been asked to spend a few minutes just talking about a community initiative set up a few years ago, the Necklace project. It's a Susan Dorst initiative. And the aim is to collect, or at least to promote the collection of time series of observations of basal melt rates around Antarctic ice shelves, and these are the key phrases there are in red. We're really aiming here for time series, and they're to be sort of in situ observations rather, for example, than remote sensed observations. I'll do is talk a little bit about the motivation for collecting basal melt rates, although I'd like to think that this audience is pretty tuned into that already. How we collect the melt rates very briefly, and then sort of where we are now, and talk a little bit about the new exciting NECLIS website, and also the sort of future directions we need to go. So collecting melt rates, time series of melt rates, there are various reasons we might want to do them. Two of the ones that were really part of the motivation for NECLIS directly were helping support numerical modeling, and also sort of helping to support satellite-derived melt rates. Validation of satellite-derived melt rates seems to be particularly important. The spatial patterns, as Irina Vankova pointed out yesterday, the spatial patterns are generally pretty good, but the temporal sort of variability has been shown to be pretty patchy in some areas, in particular on the western side of the Ronny Ice Shelf. Irina showed very effectively yesterday that they bear little, the temporal variability bears little relationship to what we observe with in situ observations. Whereas on the eastern side of the Ronny Ice Shelf, they do a really good job. The satellite retrievals do a super job. So what we really want to do is try and get to the bottom of that apparent dichotomy. As for models, if we believe that melt rates are controlled broadly by ocean conditions beneath the ice shelf, then clearly time series given of melt rates can give an indication of the varying sub-ice shelf conditions themselves, and they form a fabulous metric for validating and hopefully helping numerical models. And one really good example of how we can help them is through melt rate parameterization, trying to improve the melt rate parameterization, especially in areas where we actually have ocean data from sub-ice shelf moorings. There's a really nice example here from the Eastern Ronny Ice Shelf, presented by Elena Marenko. And this is a graph of a year-long time series showing the AP-res derived, in this case AP-res derived melt rates in black. So in situ observations of melt rates in the heavy black line, and those other colored lines show different melt rate parameterizations. And clearly with these sorts of data, we can zero in on the correct parameterization, certainly for that area, quite quickly. So how do we collect the melt rates? Well, the majority so far have been collected using downward-looking autonomous phase-sensitive radars, or AP-res. There are other methods, but we're going to focus on that one at the moment because that's the one that's been used the most. So the idea is to deploy the radar on the ice surface, and every hour or so it makes a measurement of the range between the antennas and the ice base, and also though ranges to the internal layers within the ice column. And just this is my version of Irina's nice diagram from yesterday. If this is the ice column, I don't know if you can see my cursor, but if this is the ice column at time 0 where we deploy the instrument, the ice base is down here, the ice surface is there. As time goes on, or as we move down the flow line, if you like, the ice is thinning, the ice column is thinning quite nicely. And that thinning is a result of various factors. One is the internal strain of the ice as seen by these internal layers, all sort of beginning to converge, in this case for a thinning ice shelf, and then the ice base is obviously being melted also by the ocean, and there's a surface accumulation and fernification going on at the top. And so if we can monitor the speed at which these, or the rate of change of the range between the antennas of the radar and these various reflectors, then we generate a vertical velocity profile for the internal layers. And hopefully it looks like something nice and beautiful like this, where these green blocks show the different the velocities, vertical velocities of the different parts of the ice column, and the mismatch at the bottom from the extrapolation of the strain is indeed the melt rate. So basically, when we deploy this sort of system, the time series are typically a year or more, although Necklace is interested in anything down to just a month-long time series. And the temporal resolution depends very much on the nature of those internal layers, how coherent they are and well-behaved. If they're beautifully well-behaved, we can get the temporal resolution down to just days or shorter, but it may be an order of a week or two if the ice is a little bit messed up, if the internal layers don't behave well. So where are we now? Well, the very first time series that I'm aware of, someone might be able to correct me on this, that I'm aware of was from Craig Stewart on Ross Ice Shelf, Coolman High, back in the 2013-14 season. And this is a month-long time series, very, very pretty, lots of variability, and just showing the real richness of ocean behavior that is reflected in those melt rates. And since then, we've had groups from, well, 10 nations that I've counted. There may be more, but I think it's probably around about 10 from all around, deploying instruments all around Antarctica. The time series range from 1 month to really quite a few years, 6 or 7 years in some cases. And we're getting a fairly nice coverage around Antarctica. It's obviously sporadic in both in time and space, but how sporadic it is in time is probably not that important, because certainly as far as numerical models are concerned, they can essentially pick up any data that is any sort of data period that is being collected. There are areas which are, certainly from the perspective of the British Antarctic Survey, slightly embarrassing, that the Larsen Ice Shelf, which has had a lot going on, has never had an AEP res sighted on it, nor has George VI Ice Shelf, which is the ice shelf I started out on in my career. Still very sad to say we haven't had an AEP res, any long time series of melt rates measured quite that directly all of this time. And there's also down here in Wilkes Land, our daily land, it's all a little bit looking a little bit sparse, to say the least. So we can always use more. The website is a wonderful thing to view. Recommend you go and take a look at it. It's the early days for this website. The funding was obtained by, I think, primarily Sue Cook and Sarah Thompson, actually, from in Hobart, and they managed to get this thing up and running at this site here. The site contains technical information giving guidance about deploying instruments and just the general field setup and actually in the use of the instruments. It'll also contain firmware, just the technical aspects of running the radar, documentation like manuals and just general guides really. And coming soon will be links to data and also processing scripts, pretty important. At the moment, what we're really looking for are process data sets, and it'll be down at sort of 1 month average melt rate type time series. In the future, we'd really like to have links out to the raw data, and we've got recommended ways of storing those data in data centers. If we have the raw data, then as we improve our methods of processing, we'll be able to go back and hopefully improve the analysis of the raw data. And Sue Cook is kind of on the lookout for data. So if you have any AP res data, she knows who you are, and she'll be coming knocking on your door. And I can assure you there is nowhere to hide. So you'll need to respond one way or another. So Sue will be chasing down, trying to find data sets over the next few weeks, I believe. And hopefully that once we've got some of those data sets all up and running, then she plans to put together some community paper during 2023. So that's it. Just watch out for Sue. She's coming. Thank you very much.
Thanks a lot, Keith. That was great. We have time for like one question if people want to ask something before we move on, or while we move on to the next presentation. Is there any urgent question? And feel free to either unmute yourself or type it in the chat. We can also read it if you prefer. Hearing none, seeing none, we can keep discussions also. We'll have plenty of time after all the presentations for discussion, so you can also keep your questions for later. The next presentation is from Kirstin Schulz, and she's going to talk about the GRISO initiative.
Yeah, hi, thank you for giving us the opportunity to present GRISO here. GRISO is the Greenland Ice Sheet Ocean Science Network, so other hemisphere, up in Greenland now. And GRISO has a long history that I won't go into detail here, but at the moment it's an NSF AXELNet program. And this NSF AXELNet program has the thinking of creating networks of networks to bring together science from different disciplines, different communities, different networks, to facilitate the interaction amongst these groups to, well, make better science. And who we are is, on the one hand, the steering group. That's Fiamma, Dave, Twyla, you might have heard some of these names. Donald is one of the co-organizers of this workshop. And then we have two postdocs, one of them is me, and Dom Farner, who's situated in Oregon. And we do have an advisory board consisting of these 6 wonderful women, with which we meet once a year. We write a report for them, and they give us really helpful advice to improve the work we're doing within this project. So what we started off a year and a half ago with GRISO is we conducted a community survey where we collected basically the interest and ideas that people within the community of Greenland research in general have. And that was quite successful. We got a lot of responses from different people across a lot of countries, institutions, and academic networks, all career stages represented. And we also asked for the engagement level that these people would be willing to, well, engage with GRISO at. And a lot of them were really interested in this effort that we are conducting. Based on this community survey, one of the things we did was to establish working groups with 5 different topics. Originally, we only had 3 planned, but based on this community survey, we also added like paleo and a data working group. And all of these 5 working groups have 2 leads or co-leads and a number of members, 5 to 7, distributed again across career stages and nations. So in total, we have 12 nations represented in these 5 working groups. And the aim of these working groups, they're quite free in what they're doing. It's about identifying the knowledge gaps, the most pressing questions related to Greenland within their respective fields. So it can be review papers, workshops, white papers, whatever they feel is the best thing to move forward in this topic. And GRISO, from our side, we also facilitate the cross-working group collaborations by bringing together the working group leads and also the whole working groups. And each of the working group has 1 member of the GRISO steering committee as a liaison to feedback and to not lose touch with all the working groups. Together with these working groups and a company called No Innovation, we facilitated a couple of virtual workshops at the beginning of this year, end of last year, that were not really focused on science, but more on communication, collaboration, project management. With 3 of them: creative collaboration, appreciative inquiry, and design thinking. And we got really positive feedback about that. So we learned, even if it's not science, a lot about how to communicate with people and get a feeling of how project management works and how to interact with people with different characters. And we found that very valuable. And also together with No Innovation, we did in this summer our first GRISO summer school. Should have been already the year before, but COVID. And from now on, this is going to be an annual thing that we are organizing summer school, probably in Greenland. And the topic this year was the impact of glacier retreat on Greenland's coastal margins. And we covered a wide variety of disciplines there. So it was not only like the usuals, glaciology, oceanography, ecosystems, but we also had like 2 social scientists joining the summer school. And that was a bit of a gamble, you know, bring social scientists and the natural scientists together, but it worked out really beautifully. And from both the social scientists and the natural scientists that participated, we got very positive feedback about learning from the other disciplines and getting like the broader view on the topics. And we got a very high number of applications that were all really, really good. And we only could select 12 participants from in total 7 countries, all in late PhD, early postdoc level. And we conducted the summer school in Nuuk, and there the students had the opportunity to also engage with local Greenlandic scientists from ACIAC GNR. They went to the museum, they went to local agencies, and the students found that really, really good to like get a hold on what local people and communities are about to do. To engage with like a little bit broader scientific community, we have, of course, social media presence and try to do a bit of outreach. We have a website, we have a newsletter that you can subscribe to on our website. We have a Twitter account. We do have a YouTube channel where we present networks in our network, so different projects that are associated with us. And we have a little interview series with early career researchers about their recent publications. So little 15-minute videos where just talk about what they wrote down to give them a bit broader reach with their publications. And we participate in workshops like this one and try to make GRISO a bit more known. And what we have for those of you who attend AGU, we're going to have a poster there to talk about, well, GRISO in general, and specifically the summer school and what we learned from there and how we plan to conduct that in the future. Right, so coming back to who we are, I said it's the steering group, the postdocs, and the advisory board, but this is not really true because we are way more than just these couple of people. So we are also the working group leads and the working group members. We are the connected projects and the networks that are associated with us. We are the participants of the summer school and everyone who helped with the organization of that, no innovation, everyone. We are the local communities, and what we also want to do is have as many people in our network interacting with us and with other people through us, so you can also be a part of GRISO, if you like. Right. Thank you very much. And I guess questions?
Thanks a lot, Kirstin. If there is 1 or 2 questions, we can take them now before we move on to our next presentation. Or again, feel free to post questions in the chat or keep them for the discussion that we will have after all the 5 presentations. Okay, so then we're going to move on to the next presentation from Alessandro Silvano, and he is going to talk about the Instant initiative.
Can you see and hear me?
We can hear and see your screen really well, so feel free to get started.
Okay, thanks. All right, so today we'll briefly introduce Instant, which is instability and thresholds in Antarctica. So the presentation will be quite short, so if you need more information or anything, you can just visit the website here or follow Instant on the different social medias. Okay, so what is it? So Instant is one of the scientific research program of SCAR. It's an 8-year project that started last year and is going to last until the end of this decade. And the main goal is to quantify the contribution of the Antarctica ice sheet to past and future sea level. And this is the focus because the contribution of Antarctica to the future sea level is probably the most uncertain factor in the future of the sea level, indeed, as also highlighted here by the IPCC. And in particular, the role of instabilities and thresholds in the system are very important and potentially scary for the future in terms of several tens of centimeters of sea level rise. So the idea of Instant mainly is to provide a platform or a coordinating framework to help international collaborations to initiate new consortia and basically strengthen activities around the globe. And I would argue that the main goal is to bring different communities together. And in particular, there is a strong interest in connecting paleoclimatologists with scientists that are working on the, let's say, modern time ice sheet. So this is the main idea, but also to try to connect glaciologists with oceanographers and meteorologists and geologists. So it's, as you might imagine, is a big community, and Instant is trying to put everybody together. So also Instant strongly promotes diversity and inclusions, and there are members, about 300 members at the moment, from very different backgrounds, from different countries, and many of them are early career researchers. So what Instant does to support, especially early career, is to provide some funding through fellowships to early career scientists, and also provide some sponsorship for international workshops that are either part of SCAR or not. But the idea is to help try to bring different communities together. So Instant is also part of many international events. Like, for example, it was present at COP26. It will be again present at the new one in Egypt, COP27, in less than a month, I guess. So it's also important to highlight the science that we are all doing. And so also Instant tried to put together different scientists to write papers. There was this recent special issue that focused on the Antarctic climate evolution over the geological past. This builds mostly on legacy from previous SCAR activities, but there is the plan of doing a new one over the coming years. And this is, of course, open to anybody that is willing to contribute. So moving more to the science objectives. So we are very interested in the interactions between the different components of the Antarctic system. So the interaction between the atmosphere, the ocean, and the ice sheet. But also there is a strong interest in the feedbacks and interaction with the solid Earth. And also, as I said at the beginning, there is also a strong important factor that are these instabilities, like the marine ice sheet instability or the marine ice cliff instabilities. So there will be specific working groups working on these instabilities. To do so, we organized 3 different main teams. Team 1, that is focuses on the interaction between atmosphere, ice, and ocean. Team 2, that focuses on the interaction between Earth, the solid Earth, and the ice sheet. And Team 3, that try to put everything together and better communicate the science to the stakeholders. So related to this workshop on ice-ocean interaction, I will focus today on Team 1, which is the interaction between atmosphere, ice, and ocean. So everyone that is interested in hearing more about this, feel free to write me or to Liz Thomas, the other point of contact from the British Antarctic Survey. So Team 1 consists of 4 subcommittees. So these subcommittees are basically the engine of Instant, where the activities happen. There is also a seminar series that happen bi-monthly, meaning every 2 months, and you are free to attend, and you can find online on YouTube the previous seminars. Moving to the different subcommittees, the subcommittee number 1 is called CLIP-ANT, and this is really related to this idea of the interaction between the climate system and the ice sheet. And there are 3 main activities happening, based mostly on a survey that we did at the beginning and based on the interest of the members. One is going to be a modeling effort, try to look at using couple models, try to look at the interaction between climate and the ice sheet at the last interglacial, when the climate forcing is expected to be similar to what we will see in the coming decades and centuries. So this is also collaboration with PNIP. There is a second activity that focuses more on the ice shelves and the processes that that determines the stability of the ice shelves, from basal melt to surface melt to hydrofracture and so on. And the idea is to try to write a synthesis paper over the coming years, potentially as a part of a special issue. And again, this is still very early stages, and everybody's welcome to join and contribute. And there is one that is highly related to this workshop, which is, I call it ice-ocean interaction. But the main idea is to understand the role of Antarctic currents, like the coastal currents or the Antarctic circumpolar current, as well as sea ice processes in delivering heat to the base of the ice shelves. So the idea is to better understand the processes happening here. If you can see in this schematic, looking at processes that brings heat from the open ocean to the ice cavities. So we are at the moment conceptualizing model experiments and potentially some plans for field work over the coming years to look at processes, for example, at the shelf break. So there are other three subcommittees. I will go very quickly here because the scope is a bit different. One is the subcommittee 2 that focuses on seasonal to centennial timescales using paleo records, mostly from ice cores. You can see there are many ice cores around Antarctica, but also marine sediments and other proxies. And also data simulation models using these paleo records as to be assimilated in these models to reconstruct seasonal to centennial changes over the past centuries. And there is a focus on the atmosphere ice-ocean interactions and also on the surface mass balance. The subcommittee 3 and 4 instead focus more on geological timescales. So now we're talking about thousands to millions of years. The subcommittee 3 is going to focus on trying to compile and put together all the different paleo proxies that are available and also improve age models for the different paleo records. And one main goal here is to identify what proxies are useful and where they should be collected in terms of modeling. So there is a strong connection between ice sheet modelers and paleoclimatologists. And finally, the subcommittee 4 is focusing again on very long time scales from the initiation or the initial growth of the Antarctic ice sheet about 30 million years ago to present, and look at how changes over a long time scale of the ACC or the winds affected the evolution of the Antarctic ice sheet. And again, also in this case, try to relate these past findings to future development of the ice sheet. And again, it's going to be a proxy model approach using these proxies to calibrate the ice sheet models. So how to get involved? So the easiest way to get involved is to go on the SCAR web, on the Instant website, and you will find on the homepage a way to become a member. So it's a very easy process. You can do it quite quickly, 2 minutes, I guess. You can do it, or you can have more information and contact us directly. There are very different, many different subcommittees and teams. But if you're interested, for example, in ice-ocean interaction, you can write either myself or Liz to have more information. And finally, last thing, there will be a conference next year in September in Italy, and most of the Instant community will join. And if someone interested in ice-ocean interaction want to join, they would be more than welcome. Thank you.
Thanks a lot, Alessandro, and well done summarizing such a large initiative in just a few minutes. That was great. We're going to move straight to the next presentation. So in order to make sure we stay on track with time. So if you have questions, you can either put them in the chat or just keep them for the discussion later. So the next presentation is from Jan de Rydt, and he is going to talk about the Mesomib to Marine Ice Sheet Ocean Intercomparison Project, second version, I guess. Go ahead, Jan. If you can first unmute yourself, we can see your screen, so that's good.
Excellent. That's better.
That's perfect. Thank you.
Awesome. Thanks very much, Helene. Thanks all the organizers for a fabulous workshop and the opportunity to provide a platform to share some of these initiatives and to hear what else is going on. So I'm going to spend a few minutes talking about, for those of you who don't know, the Marine Ice Sheet Ocean Model in Comparison Project version 2. Just to give you a little bit of context here, this is sort of a logical progression of a range of these MIPs that have been carried out over several years, almost decades now. And it really started in 2003 with what was then called ISOMIP, and that was for ocean-only simulations when people started thinking about implementing ice shelves into ocean models. And this was very much based on idealized setups, the so-called cheese wedge cavities, as we call them. Lots of models have since run these simulations, although I don't think these results have been published in one particular paper. That was then followed up by a range of other MIPs, both focusing on ice only, so standalone ice sheet simulations, and ocean only simulations, and then later on ice ocean simulations. So in 2009 there was the MISMIP experiment that was presented in a seminal paper by Frank Patin back in 2012, followed up by the MISMIP 3D experiments published in 2013, I believe. And then in 2016, there was a range of experiments, all for idealized cases, idealized setups, ISOMIP plus, MISMIP plus, MESOMIP 1, if you can keep track. Some of these results are still in preparation. Some of these have been published, as shown there on the list. And then, of course, there has been the ISMIP 6 and some follow-ups as well. So this is really a follow-up on a long sort of range and line of previous MIPs. And in this case, we have tried to keep it somewhat more simple in terms of acronyms, and we are continuing the line with what is now called MESOMIP 2. So it's for marine ice sheet ocean models. Okay. So just a quick slide on what the aims and the philosophy is, if you will, and that matches really well, I think, with a lot of things we're trying to achieve in this workshop and the aims of the JCIOI. So it's really to foster interaction between the ocean and the ice sheet modeling communities, and to build these stronger links now between observations and modeling communities. So as you will have heard, these previous MIPs, a lot of them were really focused on model verification and all based on idealized setups. So observations as such were not included, but that's really something we want to take forward and now also move towards realistic simulations of the ocean system and the ice ocean system in a range of Antarctic environments. So this has been going on for some time. I'm going to say a few things about the current sort of thinking about the experimental design of MESOMIP 2. So on the left there in the box, you see the models that we request to participate in this all have a realistic representation of a part of or the whole Southern Ocean. These can be regional models or global models. And the focus, though, of in the comparison will be on two contrasting shelf seas, the Amundsen and the Weddell Sea, so often referred to as a warm and a cold shelf. And the approach will very much be a come as you are. So as long as the model setup has ice shelves included, to allow maximum participation from the community. So we propose in a series of experiments, which are listed in the middle there, to do various things. The first part will be focused on standalone ocean simulations with fixed cavities. And that will be for the observational period where we actually have ocean data available and where our ocean models can be compared to those observations. In the second part, we are interested in teasing out how sensitive ocean models are to changes in cavity geometries as ice fronts change, as the grounding line locations change. And so this will be based on a series of prescribed modifications to the ice shelf geometry. And then the second set of experiments will be to repeat some of these, but in a coupled ice ocean framework. We will run the historical period again for in coupled ice ocean models, really sort of focusing on, what are the melt rates that ocean models provide, and what are the melt rates that ice sheet models actually expect, and how can we marry the two, thinking about potential initialization issues, about which we have heard quite a lot already this week. And then the final part will be looking at maybe potentially idealized forcings and future scenarios, although that part of the protocol has to be refined. Note that here we do not include any standalone ice sheet simulations. We believe that is the remit of ISMIP and other experiments, so we do not want to duplicate those efforts. So the observations will be an integral part of this, and what we aim to do is to provide what we refer to as a MIP kit. So this will be a series of data sets which are publicly available, but compiled in a useful and accessible way for the community that can be used to compare ocean model output against. So the MIP kit will be provided as part of the protocol for the MESO MIP2. It will include things like the repeat temperature and salinity sections that we have available for the Weddell and the Amundsen seas, moorings, as well as some of the available ice sheet data as well. So just a quick timeline. So the first meeting we had really with the community was back in September 2020 to discuss the protocol with interested participants. Then there was a bit of a hiatus. And today where we're at is the protocol, example simulations and the MIP are very much in progress. And the manuscript as it stands is being prepared for submission. However, we hope to release a draft manuscript to the whole community early next year, and then get updates and discuss this further, potentially in relation to an EGU splinter meeting. And this is still very much a question mark, but maybe by the end of next year, call for results and first analysis. If you want to get involved, just a final slide here on who is sort of in the driving seat. So there is Nico Jourdain at Grenoble in France. There's myself in Northumbria. Yoshi Nakayama, who's also, I believe, part of the JCIOI steering committee in Japan. And then Ralph Timmerman and Matthias von Kaspel, both from AVI. You are very welcome to sign up to the email list for this project. There is a short list of instructions. I believe these slides will be made available, so you'll have the instructions there. It involves sending an email to a particular email address with the subject line "subscribe MESO MIP2." And there is also a website, so feel free to go and have a look there. This is hosted by the CLIC, so climatecryosphere.org. And as I said, we hope to bring the community together, potentially following EGU, and we'll send announcements through the cryo list for that, and hope to get funding as well from CLIC to bring some early career scientists on board with us. I think that's all from me, so thank you very much. I'm open to any questions.
Thanks a lot, Jan. So we'll have one more presentation, so maybe we'll do the last presentation, and then we'll have plenty of time for questions and discussion. So the last presentation of these community efforts and linkages is from Ben Galton-Fenzi, and he's going to talk about the RISE initiative. So Ben, if you want to try sharing your screen, and if there's any problem, I can do it.
I seem to be having a problem. I'm sorry about this. Are you able to share?
No problem. Okay, so you can, if you can do it, I'm gonna share my screen, and this.
Oh, I'm sitting out of the house because it's an early morning for me, so I don't wake up the children.
No worry. Oh no, what happened? Share. Is that good?
That's brilliant. Thank you.
Perfect. Sure. Yeah, just let me know when you want me to move the slides.
Wonderful, thank you. Thanks for the opportunity again to talk. We haven't really broadcast ourselves too much, except for sort of beating the rug to individuals to participate. But I've been asked to talk about the Realistic Ice Sheet Ocean State Estimates project today. It was sort of formed early in mid-2019, I'd say. What I will spend some time doing today is sort of telling you sort of where we've come from, what we're up to, and where we're going with the project. Like all of these things, it might have been anticipated to be something a little bit bigger than what it's ended up. Part of the difficulty that I've had is getting sustained funding to support to kind of continue the analysis, and I imagine the other activities that we've heard about today probably suffer from the same problem. So it'd be good to talk about that at the end if we've got time. But the steering group is made up of, I'm on that, we've got Helen Fricker, David Holland, Keith Nicholls, Helene, who's here, of course, and a member of the SUS Secretariat. The analysis group really is Rick Smith and Sue Cook's very involved as well. And we've chewed through a lot of other people under previous funding in Hobart, David, Eva, and Wilma. And there's contributors from model contributors you can see that I've got listed there, and some satellite data as well. This financial support really is through the Australian Antarctic Program Partnership and the Australian Antarctic Division, and that's really to help fund Rick Smith and some of Sue Cook's time to keep this going. Next slide, please. So where did this come from? You know, this is a plot as of 2018, really, of a summary of all of the available mass loss estimates from ice shelves integrated around Antarctica from satellites, which is the top 4 bars on that plot. The 4th one there is actually another method that Eric Rignot's paper used, which doesn't have error bars with it. The bottom horizontal columns there, rows, whatever you want to call them, they're all the numerical models that were sort of available at the time, with the condition being that they had to have all of the ice shelves around Antarctica, or as many of them as possible. So some of them had less than others, like the Helmer paper, that was a very early one. And then some of the later ones have a lot more ice shelves in them, just partly due to the resolution of them. But you can see the variability of that's huge. So then the question is, well, why? Why is the variability in the ocean model so large? How can we learn more about this? Next slide, please. So like Jan, I've got a development timeline. It's pretty much mirrors what he had up there, luckily. This really kicked off. ISOMIP was really important to sort of starting this ice-ocean interaction into comparison. It was idealized, heavily prescribed experiments. This is what I call the Grosfeld model, cross-section and a top-down view of the basal melting. That led into the effort that David Holland led through the WCRP into MESOMIP, which is ISOMIP plus, and then there's the ice sheet modeling part. I'm not focusing on that at the moment. So I've called those semi-idealized, or you could call them semi-realistic domains. And again, there's a slew of papers, I think, that's coming out of that, led by individuals as well. Zylar, as A. Davis is leading the model into comparison. And that leads into where we are today, which is the Trident here. So we've got MESOMIP 2 at the top I've put, just recognizing that that's doing something similar to us, but it has a much stronger focus on the Amundsen and Weddell. The ISOMIP plus MESOMIP, I think, is continuing really. I mean, there's still some papers we need to get out of that initial get together. And then, you know, how does RISE fit? So we're Circumantarctic only, in the same way that Jan talked. It's sort of come as you are. We're just going to take everybody and everything that's available, as long as you have a Circumantarctic ice shelf ocean model. It could be a global ocean model too, but and in fact, we do have some of the contributors that are running global models. Thanks. Next slide. So the approach is to, you know, come up with ensemble model estimates of ice shelf basal melting. You know, can we look in more detail about those integrated mass loss estimates? How do they compare from ice shelf to ice shelf? What's the ocean drivers of that? Where do they disagree? Where do they agree? Very keen to make sure that we're integrating hand in glove with the observational programs of satellite-based estimates and necklace to come up with new descriptions of the processes and understanding A key activity is to identify regions of high signal to noise, actually, so and discrepancies, so we can focus field campaigns into those areas to understand them better, the differences, but also if they agree, maybe they're great sites to go and target for observational studies to monitor. And one of the last outcomes that we hope to get to is sort of how do we develop better parameterizations, of course, for ice sheet models and global climate models. Next slide, please. So this is where we're up to. These are the number of models that we have. We've got 10 contributing models. The models are listed on the third column there, and we have the contributors. The epochs of them are all very different. Some of them have only been run for 1 year. Others have been run for much longer timescales, up to 150 years. Whether or not they have sea ice, whether or not they have tides, there's only one model that has tides. Again, grossly variable resolution, very different types of horizontal discretization as well, which has been incredibly challenging to get them all onto a regular grid to start the comparison. Next slide, please. So, you know, the problem with the come as you are approach is that not everybody has all the variables that we need to help facilitate the complete analysis that we wanted to do. So this table just sort of summarizes, you know, some of the variables that we asked for, but the way we wanted to get to was getting U star and T star to friction velocity of thermal driving, and being able to figure out at that level of detail, you know, how does the boundary layer physics in the models agree or disagree, and then start to think about what the far field ocean drivers of that was. So that's a big outstanding component, and we're having to back calculate those two bits from the outputs we've had supplied to us, which is proving a little bit challenging. Next slide, please. So this is just an example. The plot on the left here shows the ensemble mean melt rate, early results, and the plot on the right shows a standard deviation. So you can see for the big Filchner-Ronne and the Ross, the models pretty much agree, and the map on the right shows that even under the Filchner-Ronne, we're getting that large area of refreezing. It seems to be that where the melting is higher, so you can see in the Amundsen Sea, George VI area, the standard deviation between the models is also higher. The Amory is a bit of an anomaly. We don't quite know why the variability or the deviation between the models is so high there. Next slide, please. This is again showing the difference between the ensemble mean and the satellites as a percentage. So if it's sort of red, it's at the high red and high blues, I should say, it's deviating by more than 300%. But again, the big ice shelves where the melt rates are perhaps a little bit lower show lower deviation from the satellites as compared to those other areas that I talked about before. Next slide, please. So we're getting to the point of being able to sort of tease out how the individual models contribute to that mean or the ensemble mean. So I'm just putting this up as an example to show how they do agree or disagree, if you want to put it that way. And again, the Amory for me is quite a standout, but there are areas in the Amundsen West Antarctic area that really do show some very strong differences. Next slide, please. And we can relate these back to what the ocean temperature is doing, what the currents are doing. So these are the variables that we asked for. It's this is the upper ocean average temperature, I should point out as well, for each of those models. So you can see that some areas have much warmer water in front of the Thwaites Glacier, for example, than others. But that's not the full story. So we've got to still think through this a lot. Next slide, please. Again, just showing as an example of Filchner-Ronne, or Ronne-Filchner in this case, the ensemble mean, I don't know if you stare at this and you're familiar with this area, maybe it's doing an okay job. Jan, I think these types of results that we're producing from RISE, it would be great to contribute that into MISMIP2 for what you're doing, and thinking about how that influences the coupled system as well, which isn't part of our mandate at the moment. Yeah, next slide, please. Again, just focusing on a different region. This is the Denman. just in a little bit more detail, just for illustration really, but you can see that the multimodal mean there on the top left is kind of muted. The standard deviation is very high. It's coarse. Some of the models are coarser than others. Very different picture with the satellite observations that show this peak melt rate near the grounding zone. If we go to the next slide, please. Part of the reason for the ocean model results is that they tend to get the currents coming in the same direction. So the warm water that's advected across the shelf front impacts onto the front of the Denman Glacier there, driving that higher melt rate. But they don't tend to produce the melting near the deep grounding line, which is interesting. Why they don't do that? We suspect that actually points to a missing process in the models, and that's the subglacial water influence. So we think there's a very strong subglacial water flux here that's driving high melt rates at the deep grounded ice. So again, that's already illustrating perhaps that we need to be thinking about including additional processes in our models. But the way that the flow comes on shelf actually and interacts with the ice there is really strongly controlled by the geometry. So, you know, it's exciting to hear that MESOMIP2, for example, is going to do some of those geometry perturbation experiments. That to me is the single biggest uncertainty or problem that we've got to try to constrain to produce better melt estimates. Next slide, please. Yeah, just an example, again, breaking it down in terms of the models that we get. So the top right's the MPAS Ocean from Xylar. You can see it's quite coarse compared to the ROMS 2 kilometer on the top left. And they give very different maps of melting. So we get a lot more refreezing in the ROMS model. But they do show on the main Denman trunk that peak of high melting, which is interesting, like I've talked about before. Next slide, please. Almost there. So yeah, where we're going, that's the state we're at. Rick's done an amazing job of getting all the models onto a common grid. I think it's 500 meters. It's oversampled basically so that we can deal with finite element versus the other systems that we have. So we're continuing to try to tease out different types of analysis. So the right-hand plots here just show some examples from Amory, Thwaites, Getz, and Filchner of the melt rate versus the thermal driving that we've calculated. And you can see for each of them, there's a sort of linear, perhaps superlinear, nonlinear relationship that's different between them as well. So we're thinking about what that means for each of these ice shelf ocean systems. You know, is there a sort of thermal driving times friction velocity relationship that we can develop for each of these systems to produce a melt rate that allows us to understand them a bit better and that we can use to parameterize in models. The left-hand plot shows it's again an example for each of the ice shelves around Antarctica. This is just a subset, actually. There's a few hundred of them. You know, we can start to tease out where the models really do agree and where they do disagree. Thank you. Next slide. So that's where we're up to. Where we're going is we again are looking to produce this initial paper within the next couple of months. It's a challenging process given all the models that we have. We're going to have to circulate the draft back out to our contributors very soon to get their own input into it. Part of the process that we're going through here is it's incredibly brave for modelers to share their raw output to expose to this type of analysis. So we're very thankful that folk have done that, and I think it's the only way that we're really going to help drive progress in the area, quite frankly. So we'll keep cracking on. Rick's funded until the middle of next year to progress this analysis. What comes next isn't clear. We might move to something that's a little bit more constrained if folk are willing to run experiments that are more MIP-like. And of course, we're very happy to provide the results to other studies as we go. Please get in touch with myself or Sue Cook if you're keen to learn more about the project. Thanks.
Thanks a lot, Ben, and we appreciate that this is really early for you. So thanks for getting up early to share that with us. So that, let me stop sharing. So that was the last of our 5 initiatives. And again, so it's great to see the breadth and range of initiatives going on into these ice-ocean interactions. There are a lot more, but these are 5 that are really interesting. And so we would like now to open it for questions and discussions about these initiatives and how we can work together as a community to make progress on that. So If you have questions, feel free to unmute yourself and ask them directly to any or all of our speakers, or you can also type them in your questions in the chat if you prefer. And I know we didn't take any questions during the presentation, so I'm sure you kept all your questions for these discussions, and now is the time to ask them.
Yeah, Helene, it's Ben again. Can I bring up the question I asked at the beginning? You know,
absolutely,
I think,
absolutely.
Yeah, so you know, I've had some experience with these MIPS now, and the biggest problem I think on really getting outputs produced in a timely way is how do you fund people to actually do the analysis, and a lot of that ends up coming through from individual agencies like we're doing, and that's, you know, Zyla was in a position at the time, he was doing that as well, and Steph Cornford, but people move around and they change jobs and it's not their primary role. You know, MIPS aren't supported. You've had experience with this with ISMIP 6. MIPS aren't supported in a very strong way, and it's a common problem. I'm just wondering if folk have any ideas about how we could do that better.
I just want to quickly second that problem, exactly for the reasons that you were talking about, Ben, that, you know, you move to a new job and this isn't maybe part of your job anymore, and it gets really challenging.
Yeah, and so I had this, as you said, I had this experience with ISMIP 6, for example. And so there are two problems I see. Like, first of all, how can people have the time to do the experiments? And a lot of them are really eager to participate, and there's really a strong interest from the community. So, but they still need to have the time to do it, and to do it in a reasonable amount of time. And when you have no incentives or for that, how can you help make sure that as much as possible can happen? And so I think that's why we're seeing more and more cases where we have experiments with models that say, as Jan was saying, like, come as you are, so that people can kind of piggyback on existing funded projects. And then for the analysis, my experience was that, like, it's people are interested and will devote the time to do it, but it's often like on their free time, if there's such a thing as free time. And so I don't know if we could, if we can make this better. Sometimes there's a bit of funding to organize workshops or help people get together, but we haven't seen any much to pay for the people's time to just look at the results and write papers. So I've had the same experience. I don't have a good answer to that. Yes, Zyla, you wanted to add something?
I mean, I just would say as well that it's a big part of the challenge seems to be that you can get funding or you can justify work with your own model, but it gets really challenging if you're a model developer to justify spending time analyzing primarily other people's work, not the model that you're paid to work on. So it really has to be a different funding mechanism entirely than what we're kind of used to do the model development and simulations. And that's where I feel really stuck.
Yes, Ben.
Yeah, it's almost a cultural problem, or just in terms of how funding's allocated, and feeding this type of discussion back into the international, from my perspective, into international WCRP, IUGG, getting it put into their strategic plans can help apply for funding through the Australian programs at least. But yeah, if you've got funding to employ a postdoc to work on a problem, typically they're working on that problem. So yeah, I don't know. Hopefully we can make the cultural shift. WCRP does have the Earth System Modelling and Observations core project now, so that's a positive sign, and so maybe we can look to make better linkages there too.
Yes, yeah, no, that might be an avenue. I mean, my understanding was that the funding is often limited, but maybe that's something that can change and might change and grow in the future. Yes, Roland, you wanted to add something?
Yeah, I just wanted to add that there seems to be a lot of diverse incentives in what's just been discussed, namely there's what's good for either an individual's performance interview or their publication record, and the question of what's, tree falls in the forest and no one is there, does it make a sound? If models are simply run and the results are not to some purpose, then it seems that the value of having done that modelling is much more questionable in a overall contribution to society. And maybe this needs to be pushed very hard as an aspect of the funding budget for the research projects, if not the individual employment contracts, when it comes to getting the support to run what are increasingly going to be quite expensive modelling activities. We're going to get tens of thousands of CPU hours from national agencies to run on big supercomputers, then the output has to be good for something more than just a publication.
Yeah, no, absolutely. And maybe that leads to another question that might be is related to many of these activities that we've seen. How is the data used and can be used further than just one paper and one result summarizing the initiative? How can people use that for further analysis? How to make sure that all these model results and all these things that people have worked on have a longer legacy and can be used in the future? And so what maybe some of you can discuss about this question: how can we ensure that the results go beyond just one summary paper comparing the models? We also have a comment from Frank Patine saying that another problem is that those MIPS often run for a very long time, and it is therefore hard to secure funding when finally the results are there. You don't want to have funding before the results are there and people made the effort. At least this is my experience. And Frank indeed has a lot of experience with running these MIPS. Yes, Felicity, do you wanted to add something?
Yeah, I just on Frank's note as well, I think that's similar for like long-term monitoring projects as well. Like, let's say you want to put a mooring out for 10 years, who's going to fund you if you don't expect to see results within the funding cycle? And thinking back to Keith's necklace talk, securing funding to deploy APRES that you can then service every 2 years or however long the battery lifetime is, but deploy for 10 plus years so that you can actually get a meaningful, like a long enough time series to be able to answer questions like variability versus anthropogenic forced changes in the ocean system. I think that it's really hard to secure that kind of funds, but we need to be able to answer the questions that are pressing. So yeah, I'd be interested to hear people's thoughts about that.
Keith, do you want to respond to that or add something?
Well, I'm happy to. I think Felicity sort of picked up a point that that's plagued me all my career, is this problem of trying to maintain long-term funding. Now, I've been working within the British Antarctic Survey, where we have a core thread of funding, but a lot of universities just don't have that. They're working from one 3 to 5 year project to the next, and if they can't maintain it's just a very difficult thing to do. So I think we also all recognise that, and that's, I think, probably where the international community can really work together. The example I'm thinking of now is in Amundsen Sea embayment, for example. We've quite a few years ago we started putting moorings in that embayment. It's been very challenging to get to them with ships, but it has been a multinational effort, and it's been a little bit, it's been sort of very variably successful, but we do have long-term records there now, and this has involved the Koreans, the Americans, the British. I mean, the Koreans have been a real backbone of it, to be honest. So, and if you have that going on, where you're able to go and turn your moorings around, you do have a feed of data. And it has worked actually for the Amundsen Sea embayments. It's worked reasonably well. But for other locations, like, I mean, we've managed to put stuff on the Ronnie Ice Shelf and for extended periods. But most of that really is using sort of effectively core funding and beg borrowing funding. It's not that well established. BAS used to have a pretty good record of having long-term monitoring, but just getting out to these sites is just difficult. It's hard work for BAS and hard work for everybody else. So it's definitely a challenge, but ultimately, I think the key is nations and groups working together, I suspect.
Yes, Ben.
Yeah, thanks. I mean, there are success stories here, and I think CMIP is one of those success stories. So people get funding to do CMIP analysis these days. And the other, from the observational side of things, I think the World Ocean Circulation Experiment is a success story as well. And I'd be very interested to hear more from the sort of pioneers on you know, those early days on getting WOS and CMIP established and running, because I'm sure they would have encountered the same types of problems that we're dealing with now. It's just a different level of granularity, perhaps. But that was before my time.
Yeah, before my time as well, and I don't really know how these things got started. So maybe as our field develop and we have more and more data and model results, hopefully there can be a legacy there, and people will use that to look at results, and doing analysis on these results might be something that's going to grow. And that's why maybe that's something important for these initiatives, is also to make sure that we do maintain access to the results, so that people can use that. So another thing that I don't know if there are other questions. Otherwise, another thing is that we've touched on, a few of you have touched on here, is how can we make sure that we work together cohesively, and like there are a number of initiatives that have more or less overlap, but how can we go further and ensuring that we involve more and more people, and then reach out to broader communities and strengthen the links between all of us and all these initiatives. So that's a question I would ask to all our speakers today, but other people can also feel free to jump in and tell us their opinion on that. So how can we move further?
I'll talk because no one else is. This forum's incredibly useful. So just an information sharing activity, actually, and learning what each other's doing on a common platform. So thanks very much for bringing it together. I'd like to know, moving forward, you know, how can we do this again, or under what other banners are available to us to reproduce it?
We'll talk briefly at the end of the session on a few future activities and that we're thinking about, but there are lots of other things that could be done. So if people are interested, they should also bring that up.
Just, if I can, just make one comment that we do at the very, very lowest grassroots level, there is possibly a way forward for sort of work over ice shelves, in as much as if we can make it have technological developments that make it cheaper to make the observations, then it is easier to integrate that into national programs. Ben, I think slightly tongue-in-cheek, raised a question in the chat about the possibility of air-deployed ADRES, and something we've discussed quite a lot in the past over the odd bit, and it's something we've actually made some progress on. But air deployed instruments generally, and there is more of this going on. That is relatively easy, and if it can be integrated again into national programs, just on ferry flights or just traveling between stations, I think that it's if you like taking the oceanographic sort of concept of throwing floats over the side of a ship, that doesn't cost much. And it's just a similar there are various environmental issues to be dealt with as well, but I think technological developments and the ability to get data back, larger data volumes back from remote stations, and that could help us. I'm sure there are a lot of other ways, but certainly that's one approach.
Thanks, Keith. Tora, you wanted to add something?
Yes. Hi, everybody. So how can we make this happen better? I remember from the Ocean Decade there were a couple of documents where fora like SORP, I don't know if SUS did that, provided inputs to highlight what is relevant for the Southern Ocean stuff. So, I mean, the more we can highlight the need for these kind of observations, let them be air deployed or ground deployed, but APRES long time series, and make that into these high level documents, then is that a way to make it easier fundable, easier doable through the national programs? I mean, Kenny is a great example with his rings initiative. I mean, he just imagined something and then suddenly there's a momentum on it. But just selecting core things like long time series of melt rates from PRES, get that into the high level documents that then trickles down and helps to establish that from the grassroots side with the national fundings, because it has been highlighted as this is a must do. I don't know, but which are these fora and how to get that in there? That's probably the main question.
Thanks, Tora. So that means that we need to get together, agree, and keep writing white papers and talking to all the program managers that we know about what it is that we think are the key relevant questions and gaps that there is, maybe. I don't know. Okay, do we have and I see there's this like people writing in the chat, so yeah, that's great. So if don't hesitate to do that. Do we have maybe time for like 1 or 2 questions or more remarks, and then we'll go on to a short break. So is there any more comment to kind of summarize or close this question before we move on to the next thing?
Well, if I can just a very quick remark in response to what Tora said. I think he's absolutely right that well, basically anywhere where we can argue our case is going to be a good thing, and finding the right sort of forum in which to do that is brilliant. So I've never known how important it is to have that remark in your proposal, your project proposal, that says, oh, and this contributes to something or other as endorsed by whatever big international organization. I've never had any feel for how much weight that carries. Quite often it gets a thumbs up from a reviewer. All I feel is that it simply can't do any harm. It's got to help. So it's a general tendency towards getting these things done. If it was possible to, I think about some of these oceanographic programs, like what's called the big float thing, where Argo float effort, where people, I mean, that's been immensely successful, I would say, and I take Ben's point about WOS as well. I mean, how on earth did he get something like that off the ground? It was just vastly ambitious, but everyone got behind it, and maybe it's because the communities are so much larger. Somehow there's a lot more weight there that can get these things moving. Because we all have to use ships and helicopters and expensive toys as well, but there they have a huge armies of oceanographers working in those areas. So I think it's I think this has got to help, is getting this high in the minds of NSF, NERC, wherever it happens to be, AD, wherever it happens to be, in order just to make it just the norm that people go out and make these observations when there's any sort of opportunity, and that the monitoring or long-term data sets is not a dirty word. It's something which we really ought to be doing.
Indeed, yeah, thanks, Keith. And there's a lot, and given the importance of the questions we're addressing, there should be a way to make this happen and find ways to coordinate these efforts. So if there are no further questions or comments, we're gonna now go take a short break. So go grab some coffee or whatever you need, and we will reconvene in about 8 minutes. So at 1:30, wherever you are. And the second part, we're going to have a number of short presentations of mostly from early career people. So stay around, and we'll reconvene at 1:30.
Yeah, thanks everyone very much for all of your talks and questions. So we'll just finish up now on a bit of an overview of what we've seen throughout the workshop, and I've really enjoyed all of the talks, and the breakout sessions that I've been to have been really stimulating. So maybe if we just move on one, please, Ellen. So the overall aims, I'm just revisiting the overall aims from the opening session. They were really to draw together the community interested in isolation interactions and to define the state of knowledge and identify the critical gaps. So we did that through having a number of keynote talks followed by breakout sessions where we were able to, together as a community, identify and articulate the key knowledge gaps. And we're just going to give a little bit of an overview of each of the 4 main sessions now. But it's a bit of a brain dump, and we've got a lot of information to sift through. But in session 1, we looked at, if you could advance on, please, and then we looked at the ice ocean boundary layer. So we heard from Maddie Rosevear and Adrian Jenkins, who talked about really the physics of what's going on that's driving melt, and then the physics of the cavity, so what's driving the flow. And some of the key things I think that that were brought out of this were around different regimes of that driving melt, so not just a shear regime, but also convection and double diffusive convection. And then Adrian Jenkins also made a really great point about distinguishing between the boundary layer and the boundary current, and how we actually determine what's driving flow. And key to this is really observations of the surface elevation. And for both Maddie and Adrian's talks, there was a definite theme of a lack of those kind of fine scale observations, but it's not just having any observations. Where we observe is incredibly important for being able to understand these processes better. If we move on to the discussion summary now, so there were some really excellent discussions around this topic, but I think probably one of the things that most struck me was that it's really important that we understand these processes, but then if we scale up to large-scale ice sheet ocean models, particularly those that are predicting sea level rise on timescales of decades to millennia, what are the crucial bits of information that we need to know? And so there's a whole bunch of questions that were raised here, and we're going to spend some time sifting through, I guess, and working working through those, and then we'll write a white paper that summarizes some of these questions. Session we heard from Nicolas, and the key kind of areas of discussion here were around submarine melt at tidewater glaciers by Becca Jackson, and she talked a little bit about measuring submarine melt, and then plume theory, and highlighted kind of 3 ways in which plume theory coupled to a melt rate parameterization is often used but untested by particularly through a lack of constrained parameters, neglecting sources of other circulation, and then the melt rate parameterization coefficients come from ice shelves or sea ice, which are different regimes than tidewater glaciers. So there's a real incentive there to collect more data, I guess, at tidewater glaciers. Nico spoke about the inclusion of ice shelves in ocean models and kind of wider shelf circulation and some of the biases that we are seeing in those models, particularly in melt rate, and where we can prioritize future research to improve those melt rate parameterizations for projections. And then the discussion, again, there were some really great questions that came out of the discussion. Breakout sessions, how do we constrain uncertainty in subglacial discharge? And that's not just at tidewater glaciers, but also in Antarctic ice shelf cavities, where it's incredibly difficult to actually measure the volume of subglacial discharge at the grounding line, but if we're not measuring it at the grounding line, I'm differentiating between it and basal melting. One of the, I guess there's a question here that perhaps is relevant for the short talks, and that's how do we calculate meltwater flux that comes from icebergs? How should ocean models account for this? So it was really great to hear the talk earlier from Anne, and perhaps there's places that we can work together a bit more there. And also, I think one of the key challenges is, again, bridging that gap between large and small scale processes and across very, very different timescales, from kind of tidal and shorter timescales through to kind of decades and centuries for projections. I'll hand over to Ellen for the third session.
Yeah, the third session was about new and emerging technologies, so how we can use a wide range of observations coming from in situ and remote sensing to learn more about these ice-ocean interactions. So Rydt and Kova talked a lot about how the APRES data revolutionized the way we understand ice-ocean interactions by being able to capture local detailed values of melt rate, and how that has completely transformed our vision of ice-ocean interactions and some of the limitations that we have from using remote sensing estimates of melt rate. And I continue to talk about other types of data, for example, how we can use the ice structure to look at ocean melting and scraping over the bed, as well as other types of measurement and using acoustic methods and things like that. But also emphasize how if we want to move forward, we need to continue and develop new technologies, working with, for example, the engineers to figure out how we can solve some of the problems we have in being able to deploy different vehicles for doing measurements, and also how we need to make sure that these observations that we're doing, and a lot of them are done still with large cruises, and how we can make sure to foster an inclusive leadership on these large expeditions and these field programs by bringing early career researchers early on, so that we can use all their new ideas and really have a nice and community working all together. During the discussion, there were lots of great discussion. A few things that stand out during these breakout were the potential for using machine learning to extract additional information that from the data sets that we already had, but also the need for new observations, for example, turbulence in boundary layer, something that we cannot currently do, but would need collaborating with engineers, for example, if we want to do that, and how we can move towards long-term observations, for example, something that that's also been brought up today about having long-term APRES, for example. The fourth session was about ice-ocean interactions for large-scale projections. So that was mostly about large-scale ice, ocean, and climate models. We had two keynote presentations. The first one from Dal Goldberg. He talked about a number of key areas for future developments, including the representation of grounding line and grounding zone, different processes happening in the grounding zone that are key for being able to capture ice-ocean ice-ocean interactions, as well as the role of model initialization on the transient, because conditions that you have, especially in ice models, conditions that you put at the beginning of your model have impact over very long time scale, decadal time scale, and so how these initial conditions impact the results. As well as the need to move towards a more advanced model that, for example, ocean models with non-hydrostatic assumptions, including tides or tidal elastic interactions, as well as the role of subglacial water channels that have been widely studied in Greenland, but not so much in Antarctica. And he concluded that one important question is that maybe we don't need to improve models everywhere, but we need to improve them in some key regions that are critical in terms of sea level projections. Caroline Begeman talked about other important processes such as calving and iceberg, and how the melt flux from iceberg impact our ocean models, something that again was brought up today again during some of our presentations, as well as the need to capture the onshore transport of modified circumpolar deep water, or the need to capture boundary layers with enough accuracy. There has been a push recently to move towards like climate models that integrate many components and have can capture the ice-ocean interaction. But she made a really important point that these models will always be limited in their, for example, in their spatial resolution. And so maybe we cannot put all our eggs in just one basket, and we need to have a hierarchy of models that go from process scales to all the way to large climate models, and how to make sure that we have this chain of models and they can talk to each other and work together. During the discussion, one thing that came back over and over again is the importance of capturing grounding zones. And this is really difficult regions because both ocean models have just very thin water layers and that are difficult to model. And also the observations that we have are limited and are biased by some of the assumptions that we make, for example, in deriving basal melt estimates from remote sensing. That is something that came back over and over again. And then some hope was people were having is that coming from new and detailed field observations, for example, from the Thwaites ITGC project, or move towards more small scale modeling of processes. And again, with this idea of having a range of different models that could talk to each other and that we could use to learn from one to the other.
Great, thanks, Ellen. So I guess just in summary now, we've again heard some incredibly excellent talks over the course of the last few days, and there's been a lot of big ideas, big challenges, and also big opportunities in terms of where we go from here, I guess. And so one of the questions that we wanted to pose to the community is how can JCIOI really facilitate helping to address some of these big challenges? And what we'll do next is summarize the workshop output into a white paper, and we'll distribute that widely and be seeking further input from all of the participants and others who are unable to make it. There might be the possibility of the formation of subcommittees or focus groups, similar, I guess, to Instant, but perhaps focused on specific questions, such as the topics for each of the sessions that we had at the workshop. And then I guess one of the things that the Linkages session in particular brought out is how do we really go about ensuring that we've got effective community collaboration. Partly that's through knowledge sharing and through getting together as we've done, but I think there's a lot more that we can do to work together well and to start to I guess, facilitate some of these programs that might be a lot more difficult to fund through university funding structures. And we definitely want all of your input on all of these things. So we'll be reaching out to you again for feedback again on the white paper. But if you have anything else that you would like to communicate, the documents for the breakout sessions are still open, and the links to those are in the workshop program that Sue circulated last week. I wanted to give a really quick plug again to our IUGG Berlin session, IUG July, I think it's the 11th to the 17th, but mid-July, and we have a session on ice sheet ocean interactions, so challenges and insights from theory, observations and modelling. And I guess a key aspect of this session is going to be talking about the challenges in scale, so from those small to large temporal and spatial scales. Abstract submissions are now open and they'll close in mid-February next year. So we really would encourage you to submit to that session. And we're hoping to also have a kind of side hall meeting to discuss ice ocean interaction as well. And then finally, to get in touch with us, please do so. So next slide, please, Ellen. Yep, we have our website. We'll be popping all of the talks. Well, Sue has already put all of the YouTube links on the website to revisit the talks from the workshop. We'll pop this one up there as well. There'll be more information about the white paper. Please do feel free to email us at the websites there, and also follow us on Twitter for information about what's going on. And once again, I really wanted to thank all of our participants. Thank you everyone who contributed talks. Thank you everyone who contributed to discussion. I've had a really, really enjoyable workshop, and hopefully we'll be able to get together to do it again. And yeah, so please do join me again in finally thanking all of our speakers. And yeah, hopefully see you in the future.
Thank you, everyone. Thank you all for participating. This isn't the end of our workshop, but hopefully just the beginning of more work together on ice-ocean interactions.